What if a number could build an infinite staircase of powers, yet still have a finite value? Today, we're diving into the fascinating world of infinite power towers, specifically tackling this intriguing equation: the square root of x to the power of the square root of x to the power of the square root of x, and so on, equals 1/2. By the end, you'll see how to unravel such a complex-looking problem using a powerful algebraic trick. First, let's visualize this infinite power tower. It's a square root of x raised to the power of another identical tower, which is raised to another, and so on, endlessly. The key insight here is self-similarity. Because the tower is infinite and repeats itself, we can replace the entire infinite part with the same variable, let's call it y. So our equation becomes y equals the square root of x to the power of y. Now, we substitute the given value for y, which is 1/2. This gives us 1/2 equals the square root of x to the power of 1/2. Remember that the square root of x is simply x to the power of 1/4. Applying this rule, we get 1/2 equals x to the power of 1/4. To solve for x, we need to undo the 1/4 power. We do this by raising both sides of the equation to the 4th power. This simplifies to x equals 1/16